Okay, next one from divisibility problems. So the statement is like this: S of n is equal to 2 into 4 power 2n plus 1 plus 3 power 3n plus 1 is divisible by 11 for all n belongs to n. Capital N means set of all natural numbers. We have to prove this statement by using principle of mathematical induction. So let us see case 1. Case 1 means true for n is equal to 1. Okay, we have to prove this statement is true for n is equal to 1, that is case 1. So S of n become S of 1. So the statement is like this: so 2 into 4 power 2 into 1 plus 1 plus 3 power 3 into 1 plus 1, and this become 2 into 4 power 2 1 2 plus 1 3 4 cube plus 3 power 3 1 3 plus 1 4. So that is equal to 2 into 4 cube means 64 plus 3 power 4 means 81. We have 264 128 plus 81. Okay, 120 plus 80 200 209 we have, and we have to show that this is divisible by 11. So how many times it is divisible by 11? So take 11, 11 1 ja 11, so carry 9 99, so 11 9 ja 99. Okay, so 209 is divisible by 11 for 19 times. So case 1 is true, therefore it is true for n is equal to 1. Okay, next case 2. Case 2 means we have to assume our statement is true for n is equal to k. Okay, we have to assume like that. Let us assume S of n is true for n is equal to k, comma k is also a natural number. K is also a natural number. Therefore, our statement become like this: S of k is equal to 2 into 4 power 2k plus 1 plus 3 power 3k plus 1 is divisible by 11 for all k belongs to n. Okay, so this is our new statement: 2 into 4 power 2k plus 1 plus 3 power 3k plus 1 is divisible by 11. So divisible by 11, that means for how many times it is divisible by 11? We don't know that, because it is just a form, it is not an exact number. So let assume 2 into 4 power 2k plus 1 plus 3 power 3k plus 1 is divisible by 11 for m times. We have to assume like this. Okay, from this we can write it as 2 into 4 power 2k plus 1 plus 3 power 3k plus 1 is equal to 11 into m, 11m. Okay, let us see continuation. Okay, continuation. Now transposing 3 power 3k plus 1 to right side, then it become 2 into 4 power 2k plus 1 is equal to 11m minus 3 power 3k plus 1. Okay, so considering this as equation number 1, now we have to prove our statement is true for n is equal to k plus 1, that is case 3. Proof for n is equal to k plus 1. So S of k plus 1. S of k plus 1 means our statement is like this: 2 into 4 power 2 into k plus 1 plus 1 plus 3 power 3 into k plus 1 plus 1. Just replace n with k plus 1. Now we have to show that this is divisible by 11. Okay. So let us simplify this. 2 into 4 power 2 into k, 2k, and write this number plus 1 plus 2 1 2 plus 2 1 2. Okay. Plus 3 power 3 into k, 3k, write plus 1 here, plus 3 1 3, and we have to split this number into two terms like this. So 2 into 4 power 2k plus 1 into 4 square plus 3 power 3k plus 1 into 3 cube, because we have the terms like this. So 2 into 4 power 2k plus 1 and 11m minus 3 power 3k plus 1, 4 power 2k plus 1, 3 power 3k plus 1. Okay. So that's why we have to split into two terms like this. Now this is equal to 2 into substitute this value, 2 into 4 power 2k plus 1 is equal to 11m minus 3 power 3k plus 1, 11m minus 3 power 3k plus 1 into 4 square means 16. We have 3 power 3k plus 1 into 3 cube means 27. Okay. So let us see continuation. Continuation. So multiply this bracket with 16. We have 11m into 16 minus 3 power 3k plus 1 into 16 plus 3 power 3k plus 1 into 27. Okay. So see the continuation. This is equal to 11m into 16. Here these two terms are like terms. Both are containing 3 power 3k plus 1. Okay. Here 16 3 power 3k plus 1s are there. Here 27 3 power 3k plus 1s are there. So take 3 power 3k plus 1 as common. 3 power 3k plus 1 taken as common. We get minus 16. Okay, minus 16 plus 27. Minus 16 plus 27. And finally this is equal to 11m into 16. 27 minus 16 means what we get? It is also 11. So it become 3 power 3k plus 1 into 11. Okay. So take 11 as common. We have 16. Take 11 as common. We have 16m plus 3 power 3k plus 1 in bracket. And what about this number? It is also a natural number. Okay. So we have to treat as t like that. Okay. So then let us suppose this is st. So s of k plus 1 is equal to 11 into t. So that means what we have, s of k plus 1 is divisible by 11 for t times. Okay. So finally it is also true for n is equal to k plus 1. Hence it is true for all values of n by the principle of mathematical induction. Okay. So that is the proof. Thank you.